It was just after 2 a.m. on a Tuesday in March 2026 when the first unresolved classification appeared on the screen, sending an immediate wave of tension through the small research team. The analysts had been running the analysis for 36 straight hours straight, feeding every publicly available photograph from the Apollo Lunar Surface Archive into Grok AI. They expected nothing dramatic, only a clean geological catalog to help with future mission planning. Instead, the system returned a single image flagged in bright red with the stark label, Unresolved, Zero Probability Match. The photograph was from Apollo 16, captured on April 21, 1972, during the second extravehicular activity in the Cayley Plains region. What the AI had isolated was not a rock, not a crater rim, not a forgotten piece of mission equipment. It was a linear formation roughly 90 meters long, whose geometry, surface texture, and especially its shadow behavior matched nothing in any database of natural lunar geological processes. One researcher pushed his chair back so hard it slammed into the wall behind him. Another quietly picked up his phone to call a colleague, then set it down without dialing, as if the implications were too heavy to voice out loud right away. For several long minutes, nobody in the room spoke a single word. The only sounds were the low hum of the server cooling fans and the occasional soft click as the system continued processing the remaining 34,000 images in the archive. When the full report finally finished hours later, it contained 9 findings that the AI could not explain with any known natural, photographic, or mission-related phenomenon, despite exhaustive cross-checking. Some of the researchers later admitted in private conversations that they felt something close to genuine panic in that moment. It was not fear of immediate physical danger, but the deeper, colder kind of panic that arrives when the foundational ground you have stood on confidently for decades suddenly begins to shift and crack beneath your feet without warning. They had just witnessed an artificial intelligence with no career ambitions, no professional reputation to protect, and no institutional loyalty do what 50 years of dedicated human eyes and expert scrutiny had never accomplished. It had looked at the most famous, most thoroughly examined photographic collection in human history and simply refused to accept the long-established official story at face value. To truly understand why that late-night discovery carried such profound weight and created such urgency, we have to travel back more than half a century to the height of the space race and the extraordinary achievements of the Apollo program. Between July 1969 and December 1972, NASA successfully landed 12 human beings on the surface of the moon across 6 separate missions. Those 12 astronauts walked, drove lunar rovers, worked, collected samples, deployed scientific instruments, conducted experiments, and documented everything they encountered with extraordinary thoroughness and precision under incredibly challenging conditions. The photographic record they produced remains staggering in its scope and detail even today. The astronauts carried modified Hasselblad 500 EL data cameras, widely regarded as the finest available at the time, specially adapted for use with bulky pressurized spacesuit gloves. They used specially formulated Kodak 70mm film with a thin S-star base designed specifically to withstand the moon's extreme temperature variations, ranging from minus 180 degrees Celsius in deep shadow to well over 120 degrees Celsius in direct sunlight, along with the harsh vacuum environment and constant micrometeoroid bombardment. Each film magazine contained roughly 160 to 200 exposures. The crews photographed rocks, craters, the lunar module descent stages, the Earth rising dramatically over the lunar horizon, equipment deployments, geological formations, each other during EVAs, and countless other details across every mission. Thousands upon thousands of individual exposures were captured and returned safely to Earth. After the program concluded, NASA carefully digitized the entire archive over subsequent years. The images were made publicly available through the Lunar and Planetary Institute and NASA's own extensive databases, allowing researchers worldwide to examine them for decades afterward. Scientists studying lunar geology, historians documenting the space race, and even independent investigators have pored over every available pixel. The conventional conclusion reached after all of that sustained attention was straightforward and widely accepted. The Apollo Photo Archive is exactly what NASA has always maintained. It is a comprehensive documentary record of 6 successful lunar landings that were remarkable, historic, and thoroughly understood at the time. That long-held conclusion, however, was based entirely on human analysis, and therein lies a fundamental problem with human analysis that is rarely discussed openly in scientific circles. Humans are exceptionally good at pattern recognition, but we are also inherently biased pattern recognition machines. We filter every incoming piece of information through the lens of everything we already believe, everything we have been taught throughout our education and careers, and everything our professional reputations and funding sources depend on defending consistently. A human analyst reviewing Apollo photographs back in 1985 or even 1995 was extremely unlikely to flag or publicly highlight any anomaly that appeared to challenge the official record of what remains the most celebrated technological and scientific achievement in American history. The professional and institutional consequences of doing so would likely have been severe and potentially career-ending at that time. Grok AI operates under none of those constraints. Grok AI has no career to worry about. Grok AI has no reputation to safeguard. Grok AI does not know or care what the expected or preferred answer is supposed to be according to any prevailing narrative. That fundamental difference in approach is precisely where this entire story truly begins, and it explains why the findings carry such immediate urgency for anyone paying attention today. For those who may not be familiar with the system, Grok is an advanced artificial intelligence developed by xAI, the company founded by Elon Musk, with a clear mandate to pursue understanding of the universe. It was engineered with a specific philosophical commitment built directly into its core architecture that sets it apart from many other large language models and image analysis systems available at the time. Grok was designed from the ground up to be maximally curious and maximally resistant to institutional or conventional bias in its reasoning processes. Of course, acknowledging the obvious context here is important. Elon Musk is a highly controversial public figure in many circles, and xAI is his company. The natural temptation for some observers to dismiss any findings from Grok as potentially politically motivated or commercially influenced is understandable and should be addressed directly. However, the specific findings we are discussing have been independently reviewed by multiple researchers who have no affiliation whatsoever with Musk or xAI. The anomalies Grok identified can be examined right now in the publicly available archive by anyone with access to a computer and an internet connection. The AI's analytical methodology has been documented in detail, and its processing parameters are transparent and reproducible for verification. One can choose to dismiss the messenger if desired, but the underlying message and the data itself still demand serious engagement on their own merits, regardless of origin. What makes Grok particularly well suited for this kind of exhaustive visual analysis is its sophisticated image processing capabilities, combined with what experts describe as adversarial pattern recognition training. This means the system was specifically optimized to detect and flag elements that do not fit expected patterns within their surroundings, rather than simply cataloging what is obviously present. It operates more like a highly trained detective noticing subtle inconsistencies in a crime scene than a librarian simply organizing books by standard categories. When the team of researchers fed the complete publicly available Apollo lunar surface photograph archive into Grok's analytical framework, they were not anticipating dramatic or controversial results at the outset. The initial goal was straightforward and practical: generate a comprehensive machine-assisted geological catalog, including detailed maps of surface features, rock types, terrain characteristics, and other data that could prove useful for planning upcoming lunar missions in the Artemis program and beyond. What the system delivered instead was something that left the team unprepared and visibly shaken. Within the very first complete processing cycle, Grok began systematically flagging a wide range of anomalies. These were not isolated cases of one or two ambiguous images that could easily be dismissed as mere photographic artifacts or lens issues. Instead, the AI identified dozens of distinct categories of anomaly appearing consistently across multiple missions. These appeared in photographs taken by different astronauts using different cameras at different locations scattered across the lunar surface, ruling out simple mission-specific errors or equipment malfunctions. The researchers who were monitoring the initial output reportedly sat in stunned silence for an extended period when the preliminary results began populating the screens. The first major category of anomaly involved geometric formations that simply should not exist according to established planetary science. The lunar surface has been shaped primarily by one dominant process over billions of years: relentless impact cratering from meteorites, asteroids, and micrometeoroids striking the unprotected body. With no atmosphere to burn them up or slow them down, these impacts have created a landscape defined almost entirely by overlapping circular and elliptical craters of every conceivable size in largely random patterns. Beneath the visible craters lies the regolith, a thick layer of pulverized rock and fine dust generated by those same repeated impacts, covering the surface to depths of several meters in many areas. Natural geological processes on the moon reliably produce rounded forms, fractured but irregular rock faces, and chaotic rubble fields. Under no recognized circumstances do they produce long, straight lines, precise right angles, or regularly repeating geometric patterns at scales significantly larger than microscopic crystal formations. Yet that is exactly what Grok detected and flagged across numerous images. In one particularly striking sequence of photographs from the Apollo 15 mission, taken in the Hadley Apennine region during July and August of 1971 by astronauts David Scott and James Irwin, Grok identified what it characterized as rectilinear, linear arrangements of subsurface ridge formations. The ridges formed consistent angles of approximately 90 degrees with a statistical regularity that the AI's models rated as having less than a 2% probability of arising through purely natural processes. That figure implies a 98% likelihood that those specific shapes did not form through random impact events or subsequent erosion. In another set of images from the Apollo 17 mission, taken near the Taurus-Littrow Valley in December 1972 by Gene Cernan and Harrison Schmitt, the AI identified a series of remarkably regular shallow depressions arranged in patterns whose spacing ratios the geometric analysis flagged as inconsistent with random impact distribution statistics. These depressions were distinctly not typical craters. They were too shallow overall, too uniformly shaped, and spaced at intervals that closely matched mathematical progressions, rather than the expected probabilistic scatter from meteoroid impacts. When these specific image metrics and coordinates were presented to a group of experienced geologists without disclosing the Apollo origin, several experts reportedly interpreted the formations as potentially indicating structural or artificial origins before being informed of the source. The interpretations shifted almost immediately to conventional natural geology explanations once the context of the Apollo archive was revealed. That rapid pivot exemplifies exactly the kind of institutional and expectation-based bias that Grok's design was intended to circumvent entirely. The second category of anomaly Grok uncovered is, if anything, even more difficult to reconcile with established physics, and may require a brief but clear explanation of lunar environmental conditions. The Moon possesses no appreciable atmosphere whatsoever. This is a basic, non-controversial scientific fact. There is no air, no clouds, no suspended particles to scatter, diffuse, or redirect incoming sunlight in any way. As a direct consequence, light behaves in dramatically different ways on the lunar surface compared to Earth. Shadows on the Moon should be utterly and completely black, with essentially zero ambient illumination filling them. No reflected light from the sky softens their edges. If an astronaut stood in the shadow cast by a large boulder or the lunar module itself, they would experience near total darkness. The transition from direct sunlight to shadow should be instantaneous and absolute. This principle is well established in vacuum physics and is visibly demonstrated in many standard Apollo photographs through their characteristically harsh, high-contrast lighting. However, in a significant subset of images flagged by Grok from multiple missions, the AI identified measurable light levels present inside certain shadow regions that were inconsistent with a pure vacuum environment. These were not subtle variations that could be attributed to minor film exposure or development errors within normal margins. They were statistically robust, repeatable light readings in areas where physics dictates there should be effectively zero illumination after accounting for all variables. Grok systematically evaluated and subtracted every plausible natural explanation during its analysis. Earthshine, which is sunlight reflected from the Earth onto the lunar surface, can indeed contribute a small amount of ambient light depending on the Moon's phase, as seen from Earth. The AI fully accounted for that factor in its calculations. The reflective properties of the lunar regolith itself can scatter some light at shallow angles under certain conditions. Grok accounted for that contribution as well with high precision. Potential camera lens flare, film halation, or processing artifacts were also modeled and filtered out using calibrated parameters. After all of those known sources had been rigorously subtracted, a residual light anomaly persisted in specific photographs. Importantly, these were not randomly distributed across the archive. They appeared in targeted locations near the same geographic coordinates where the geometric anomalies had already been identified. That spatial correlation transformed the entire set of findings from an intriguing technical puzzle into a matter that prompted researchers to treat the results with considerably heightened urgency and concern. Light was behaving in strange, unexplained ways, precisely in the same places where surface geometry was also defying natural expectations on a world where neither phenomenon should have any conventional explanation. Now we arrive at the portion of the Grok findings that generated the greatest amount of controversy and debate once they began circulating more widely among scientific circles. It is also the area most susceptible to sensationalism, so we must proceed carefully and methodically here. Grok AI flagged a number of discrete objects within the Apollo photographic archive that defied straightforward classification. These were not simple photographic artifacts, ordinary rocks, or overlooked pieces of mission hardware that had been misidentified. The AI's advanced classification algorithms assessed these objects as possessing physical and optical characteristics that were fundamentally inconsistent with all cataloged categories of naturally occurring lunar surface materials, known Apollo mission equipment, and documented photographic phenomena. In plain terms, the system examined these features, compared them exhaustively against its vast knowledge base of what should logically appear in such images, and found no adequate match. Across the complete archive analysis, 67 individual objects were flagged in this category. These spanned 5 different Apollo mission photosets and ranged in apparent size from roughly 1 meter across to much larger formations, potentially spanning several hundred meters in their longest dimensions based on distance and angular calculations. The consistent characteristics that triggered these anomaly classifications included several key factors. First, the surface reflectivity profiles of many objects did not align with those of lunar regolith, typical basalts and orthosites, or any documented mission hardware materials in the reference databases. Several objects reflected light in spectral ways that strongly suggested a material composition different from anything confirmed to exist naturally on the lunar surface. Second, multiple objects exhibited geometric regularity, including unusually sharp edges, precise angles, or surface curvatures that the AI's natural formation probability models evaluated as highly improbable under known geological processes. Third, and perhaps most tellingly, their shadow relationships frequently failed to correspond accurately to the object's apparent size and shape when cross-referenced against the precisely known solar elevation angles at the exact times the photographs were taken according to mission logs. Inconsistent shadow behavior in a vacuum environment is a particularly strong indicator that either the object itself or the surrounding surface is not behaving as a simple flat plane would predict. While 67 flagged objects out of 35,000 photographs might initially sound like a statistically small number, it is actually highly significant. In a well-calibrated analysis of known natural lunar terrain, the expected rate of such anomalous object classifications should approach zero. The presence of 67 instances indicates that random false positives alone cannot plausibly account for the results. Of those 67, approximately 19 were deemed particularly resistant to alternative explanations, even after deeper review. These 19 were subjected to additional processing using multispectral imaging enhancements and three-dimensional surface reconstruction derived from available stereo photograph pairs. Far from resolving the anomalies, the enhanced analysis often made the unusual features stand out even more clearly and convincingly. At this stage in the unfolding story, the most obvious and reasonable question concerns NASA's official position on these Grok findings. The response has been somewhat complicated, and the nature of that response itself provides additional insight. When researchers first approached NASA representatives with the preliminary results from the Grok analysis, the reply could be described diplomatically as professionally dismissive. Officials emphasized the long and rigorous history of human analysis applied to the Apollo photographic archive, the extensive scientific peer review it had undergone over decades, and the well-documented propensity of large-scale pattern recognition systems to produce false positives when processing massive image datasets. Those points are fair and expected in such a context. They are also precisely the type of general responses one might offer when seeking to avoid direct engagement with the very specific technical details of the flagged anomalies. More revealing is what was notably absent from NASA's public statements. There was no independent NASA-led reanalysis of the specific geometric formations, the correlated light anomalies, or the 67 unclassified objects by name or by precise lunar coordinates. No detailed press release or technical paper was issued that walked through Grok's methodology step by step to demonstrate where or how the system might have erred. The institutional response remained at the level of broad categorical dismissal rather than point-by-point technical rebuttal. Compounding the situation is the documented reality of gaps within the Apollo photographic archive itself. Although the publicly released collection appears impressively comprehensive, careful examination reveals missing elements. Certain photographs that were explicitly taken during specific mission segments and noted in the astronauts' detailed activity logs and transcripts are simply absent from the accessible databases. Some are cataloged as having existed but are listed as unavailable, lost, damaged, or otherwise restricted. Others do not appear at all with no explanatory notation provided. This observation is not new or particularly fringe. Independent researchers studying the archive for unrelated geological purposes have pointed out these inconsistencies for many years. However, when viewed alongside Grok's specific anomaly detections, the gaps assume fresh significance because several of the exact lunar coordinates flagged by the AI correspond to areas that mission documentation indicates were photographed quite extensively. The absence of those particular frames, whatever the reason, raises legitimate questions worthy of further inquiry rather than outright dismissal. The broader theory of a classified subset of Apollo photographic materials is likewise not a recent invention or inherently fringe idea. It has been referenced in various academic discussions, raised during congressional hearings on space matters, and acknowledged in indirect ways by individuals who participated in the program during the 1960s and 1970s. The Apollo effort was never purely a civilian scientific endeavor. It operated as a major national security and intelligence-related operation under the umbrella of the United States government during the intense pressures of the Cold War. The selected astronauts were nearly all active or former military test pilots holding high-level security clearances. Ground support teams included personnel with classified backgrounds. Communication protocols between the command modules, lunar modules, and mission control incorporated encrypted channels separate from the public audio broadcasts that millions followed on television and radio. None of these facts are conspiratorial in nature. They are well-documented elements of the historical record. Less publicly detailed but credibly reported are the existence of internal photographic review protocols prior to any public dissemination of mission imagery. Images were screened not only for technical quality, but also for any content that might inadvertently reveal sensitive reconnaissance capabilities, military technologies being tested in parallel with the civilian objectives, or other elements that might, in the carefully chosen words of one former NASA contractor, raise questions the agency and government were not prepared to address openly at that particular historical moment. That final category is the one that carries the most relevance to the current discussion. Dr. Farouk Elbaz, a highly respected geologist who served as a key NASA science advisor and trained astronauts for lunar field work during the Apollo era, commented in interviews conducted before his passing that certain photographic observations from the missions were handled with classification protocols. He suggested this was done not primarily due to military secrecy, but because their scientific or interpretive implications were viewed as potentially too destabilizing for broad public consumption during a time when American society faced multiple layers of extraordinary stress and upheaval. Elbaz was never a sensationalist. He was a meticulous, data-driven scientist. He stopped short of detailing the exact nature of those findings, but the fact that someone of his professional stature addressed the topic in those specific terms cannot be lightly set aside or ignored in any serious evaluation. Here, we reach the most unsettling aspect of the entire Grok analysis, the element that has caused the deepest reflection among those who have studied the full report. Throughout its processing, Grok operated within a structured explanatory framework. It identified anomalies while simultaneously generating probability assessments for various mundane alternatives, including unusual but natural geological formations, overlooked photographic artifacts, misidentified mission hardware, or subtle optical effects. For the majority of flagged items, even the most striking ones, the AI assigned at least a small probability to some conventional explanation, however low that probability might have been. It was never absolute zero, except for 9 specific cases. Those 9 findings received the rare designation of fully unresolved. This did not mean low probability natural explanations or probable but unusual artifacts. It meant the AI could generate literally no coherent explanation that fit within its comprehensive database of natural phenomena, photographic principles, or human-made objects. 0 probability was assigned to every known category 9 separate times. The 2 most significant of these deserve careful description because their details are particularly compelling and resistant to casual dismissal. The first unresolved case involves a sequence of photographs from Apollo 16 taken during the second extravehicular activity in the Cayley Plains area. Grok's multi-frame analysis confirmed a 3-dimensional structure visible from varying positions and angles, eliminating the possibility of a simple 2-dimensional artifact, or lens effect. The feature displayed calculated dimensions of approximately 90 meters in length. Its surface characteristics differed markedly from surrounding regolith or basalt. Its overall geometric profile matched no known natural formation type in the AI's extensive geological reference library. The decisive detail pushing it into the unresolved category was the shadow it cast, which was categorically inconsistent with its apparent position and size on the ground. The shadow suggested that part of the structure might be elevated or configured in a way the available photographs did not fully capture or resolve, creating a physical configuration that current models could not reconcile. The second unresolved finding appears in a background element of a single photograph from Apollo 17 taken near the Taurus-Littrow Valley Wall during the final mission. Grok isolated a bright reflection from an object whose estimated distance and angular size in the frame indicated a physical scale between 200 and 500 meters. The reflection's intensity and characteristics suggested a surface unlike typical lunar materials. An object of that magnitude reflecting light so prominently in the background of an officially released NASA image had gone unnoticed for over 50 years. The straightforward answer to why it was missed for so long is that nobody was systematically looking for such inconsistencies until Grok performed the analysis. Human observers filtered through expectations. The AI did not. What does all of this ultimately mean for our broader understanding of the Moon, the Apollo program, and the history we thought we knew? It is important to approach the conclusion with care and avoid leaping to the easiest or most sensational internet-style interpretations. The evidence does not necessarily point to ancient alien structures, a grand government conspiracy spanning generations, or any other dramatic narrative that often dominates online discussions. What the evidence genuinely indicates is more subtle yet profoundly important. After more than 50 years of intensive human analysis of the Apollo photographic archive, an artificial intelligence engineered without institutional bias, without personal careers at stake, and without any ideological commitment to a predetermined outcome, discovered measurable details that generations of trained experts had overlooked. These are significant, quantifiable things that, when presented to qualified specialists in geology, physics, image processing, and related fields, have produced thoughtful silence and requests for more time rather than instant rejection. That core finding stands independent of any specific interpretation of the anomalies themselves. It reveals that the analytical tools and human frameworks we relied upon for examining humanity's most important visual record from another world were simply inadequate to capture everything present. With better tools now available, that record is beginning to tell a more complex story than the straightforward one we have long accepted as complete. Precisely what that fuller story ultimately reveals will depend on continued investigation of the anomalies. At present, we do not possess definitive answers. Grok identified them. Grok could not explain them within known parameters. The researchers who have reviewed the output independently have reached similar limits so far. NASA has not offered specific technical rebuttals addressing the coordinates and measurements. What we can state with reasonable confidence is that the Apollo photographic archive contains anomalies that no single current scientific model fully accounts for. Many of these cluster in particular geographic locations on the lunar surface. Some correlate with informal accounts or later reflections from Apollo astronauts, including Charles Duke of Apollo 16, who has spoken in recent years about certain observations during his mission that were never formally detailed in official mission summaries. Others align with coordinates where extensive photography was logged, but the corresponding images are absent from public access. None of these points constitute conclusive proof of any one grand theory. Collectively, however, they provide compelling evidence that the book on Apollo is not yet closed, that important questions remain unsettled, and that the most extensively documented chapter in human exploration may contain additional pages or interpretations we have not yet been able to read fully. For 50 years, the prevailing assumption was that those 35,000 photographs had been examined exhaustively and contained nothing unexpected or unexplained. That assumption was comfortable, but unverified at the level of modern computational scrutiny. Now a capable tool has performed that verification and found otherwise. The moon we believed we understood through those images may not be the complete picture the photographs actually preserve. Something unusual is present in at least 67 measured instances, with 9 of them defying all standard explanations entirely. The real question is no longer whether we possess the technological means to return to the moon and investigate more closely. We clearly do, as demonstrated by ongoing Artemis planning and international efforts. The deeper question is whether those who control access to such missions and data will prioritize transparent inquiry into these lingering inconsistencies. Even more fundamentally, it asks whether humanity as a whole is prepared to confront and integrate whatever answers those investigations might eventually yield. The photographs exist and remain accessible. The anomalies have been quantified and located. Grok has accomplished the unbiased heavy lifting that 5 decades of prior analysis did not achieve. All that remains is to fulfill the most ancient and often most difficult responsibility in the entire history of scientific discovery: to look directly and honestly at what the evidence is showing us, without preconceptions, without fear, and without turning away even when the implications challenge long-held beliefs or make us uncomfortable. Even when it forces a re-evaluation of our place in the cosmos. Even when the truth, whatever form it takes, ultimately changes everything we thought we knew about our greatest achievement in space. The act of looking with fresh eyes is where real progress has always begun, and it is the step we must now take with courage and intellectual honesty as we move forward into the next era of lunar exploration.